Hello everyone, good morning, good afternoon, and good evening, and welcome to today's session. My name is Raghunandan, and I'm Technical Lead Switching ERT with HPE Aruba Networking. I'll be covering a feature introduced in AOS-CX 10.16.001 called Hibernation for AOS-CX switches. So let's get started. In today's agenda, we're going to cover overview of the Hibernation feature, use cases, detail of the Hibernation, configuration of the Hibernation feature, best practices which we need to follow while configuring the Hibernation feature, followed by demo. There is always a demand for sustainable and green IT operations. And as all of you know, Aruba AOS-CX switches are designed with energy efficient features to minimize the power consumption. With AOS-CX 10.16, we are introducing a new feature called Hibernation for AOS-CX switches. This feature enables customers to minimize power consumption across their network infrastructure during the non-business hours, or you can say period of inactivity or off business hours, thereby enhancing the energy efficiency of the network switches and reducing the overall energy cost. Additionally, this feature is delivered with customizable configuration options aligned to the customer specific business requirements. With comprehensive planning and detailed assessment of the existing network infrastructure, this feature can reduce significant amount of power consumption, thus by reducing the cost. Hibernation is a low power state in which the switch become non-functional, which is very similar to the switch being powered off. So what is the difference here? The important distinction here is, unlike a traditional power off, a switch in hibernation can automatically power on under specific conditions like automatic wake-up trigger, which means the switch will power on automatically when the pre-configured hibernation expires. While the switch can wake automatically after the set time, which means the pre-configured hibernation timer expires, which is the default behavior of the hibernated switches. Hibernation can also force exit manually. For example, in certain circumstances or as per your business requirements, you may need to manually wake up the switch forcefully from the hibernation mode. So we have two options available for the force exit of the hibernation. One is press the mode button. By pressing the mode button, it will immediately forces the switch to exit the hibernation. Second option, power cycle of the switch, that is turning the switch off and back on will also exit the hibernation. From the below illustration, you can see it is clear that enabling the hibernation mode significantly enhances the energy efficiency of the network switches, leading to overall reduction in the energy cost. Let's have a look into the platform support. With the 10.16 release, hibernation feature is supported on 6300 switches. All the models of the 6300 are supported, including the VSF stack. It is supported on 8325H switches and it is supported on 9300S switches. Also, please make a note, it is already supported in AOS 2930M switches. Let's consider some of the use cases and also understand the importance of implementing the hibernation. In campus and small office environments where the period of inactivity, which means the overnight, weekends, holidays, off business hours, present key opportunities for energy conservation. And if you consider the large enterprise environment with their scale and always on infrastructure, offer even greater potential for energy savings. If you consider the hibernation, right? Hibernation is a planned event and you can only configure it on specific switches. You cannot configure it on all of your network switches. But with the plan, right, you can configure it on some specific switches. For example, you normally wouldn't prefer to do the hibernation of a switch which is connecting from one building to another building for backups. But normally, in the normal scenarios, you prefer to do it or you prefer to implement the energy saving measures at the access layers where the end devices such as computer, phones, printer, and other network devices are connected, which can lead to a significant impact on reducing overall energy cost. By carefully planning and implementing energy efficiency strategies at the access layer, organization can reduce the power consumption, optimize energy use, and ultimately cut down on cost. Additionally, if you come to the indirect energy savings, the energy saving is not only the one from the switch itself, but potentially the saving induced by reducing the air cooling in the telecom rooms. Hibernation has a direct positive impact in relaxing constraint on air cooling systems. Let's have a look into the power consumption and energy conservation. Power consumption of the switch is measured as sum of the PSU power loss, system power, and PoE power. PoE power is the direct power utilized by the PD or PoE devices which is connected to the switches. On the other hand, the system power is the power utilized by the switch itself, and the utilization is based on whether the system is running on idle or link up or during the switch carrying 10% of the traffic, or it is fully utilized, that switch is carrying 100% of the traffic. So on the right hand side you can see the graphical representation where it is simple to understand the power consumption of the switch with the different switch states. That is, when the switch is carrying 100% of the traffic, the nominal power consumption of the switch will be 184 watts. And if the switch is running with the 10% of the traffic, the nominal power consumption will be 173 watts. And if the switch is up and in idle state, then the power consumption of the switch will be 115 watts. And if the switch is up, links are up, connected, but there is no traffic flowing across the switches, then the power consumption of the switch will be 168 watts. The point to note here is the hibernation. So you can see when the switch is put into hibernation, then the power consumption of the switch should be 37 watts. So you can see the significant decrease in the power consumption here. Let's make some assumption to understand the impact of the hibernation on power savings. Assume a 6300 switch with JL670A power supply unit on it. And we are assuming an environment where the switch can be powered down or hibernated for 5 hours at night during the working days of the week. So as we have seen in the previous slides, the nominal power consumption where the switch is handling the 100% of the traffic, the power consumption of the switch is 184 watts. So if we calculate the energy consumption for 5 hours of the day, we can see 920 watts per hour consumption by the switches. And if we calculate the same for one working week, then we can see the power consumption of the switch or the energy consumption of the switch will be 4600 watts per hour. Why it matters? This is the wasted energy when the devices are not in use. You can multiply by the number of switches in your network and you can see the unnecessary cost and carbon impact add up quickly. So with hibernation feature from 10.16, switch can be put under periodic hibernation for these 5 hours. You have seen in the previous slide the power consumed during the hibernation is 37 watts. when the switch is put under the hibernation. So when you calculate the energy consumption for 5 hours of a day, you will see the switch energy consumption is 185 watts per hour. And if you calculate the same for one working week, it will become 925 watts per hour. In addition to that, in the below table, you can see the power savings of other traffic scenarios, what we discussed in the previous slides. In the different switch status, what is the instantaneous power consumption? And if we compare the same with the hibernated the power consumption during the hibernation, you can see the percentage of reduction in the energy. If we consider the idle state and when we compare it with the hibernation mode, you can see there is a gradual decrease of 14.13 percentage of reduction of energy for this is the percentage of power saving per working week. So you can see 14.13 percentage for one particular switch, and same calculation is carried up for link up, 10% of the traffic and 100% of the traffic, and you can see 16.24, 16.44 and 16.64 respectively. Here, to highlight energy saved per switch per week, that is 5 days for a single switch, up to 3675 watts per hour. This is the energy saved per a switch for a single switch per week, that is for 5 days for 5 hours, right? So percentage reduction in power consumption is up to 16.64 percentage. This is the significant amount of reduction in the power consumption, and you can multiply that by the number of switches, and you can see the unnecessary cost and carbon impact add up quickly. Let's have a look into the details of the hibernation feature. In this slide, we can see summarized points of the hibernation feature, supported hibernation platforms, and the configuration options. As we have seen in the supported platform slide, the supported platforms are 6300, all models of the 6300, including the VSF stack, 8325H switch, and 9300S switches. In addition to this, hibernation is already supported on AOS 2930M switches. If you come to the configuration options available to configure the hibernation, hibernation can be configured via CLI and REST. The other options like SNMP, Web UI, the configuration via SNMP or Web UI is not available with the initial release of 10.16. Different modes of hibernation. With the 10.16, we have two modes of hibernation available. That is, one is immediate hibernation, that is hibernate now. As soon as you configure the hibernation, switch will enter the hibernation mode. And the other one is recurring hibernation mode or the periodic hibernation, where you can configure the switches with the schedules as per your with multiple schedule as per your business requirement. That is for multiple specific days and time, weekly, weekends, daily, monthly. Hibernation exit method, what is supported and what is not supported. Hibernation timer expiry. This is the default behavior. If your pre-configured hibernation period expires, the switch will come out of the hibernation and start operating normally. And a couple of other options available to force exit the hibernation. One is pressing the mode button and power cycle or cold reboot of the switch. These two options will help you under some circumstances where you want to force exit the switch from the hibernation mode. So where you can press the mode button or you can power cycle the switch, both the option will help you to exit the hibernation forcefully. No wake on LAN support. That means you cannot wake up a hibernated switch from a remote location. That is not supported. Let's have a look into some of the hardware status while the switch is in hibernation state. PoE is powered off. That is, there is no power over Ethernet. The connected power over Ethernet devices like PD devices like phones or APs will not get power or will not be supplied power from the switch. CPU will be powered off. There is no traffic flowing through the switch. Fans are turned off. Second PSU or redundant power supply turned off. Let's consider if you are using a 6300 switch or 8325 switch and you have two power supplies on it. During the hibernation, one of the power supplies will be in the on state and the second power supply will be turned off during the hibernation. But in case of 9300S switches, both the power supplies remain on for the redundancy. So you may have a question, what if the 6300 is running with a single power supply? So if the 6300 or 8325H have switch running with a single power supply, then the power PSU unit will be turned on or will be in the on status during the hibernation. PSU powered on, that is PSU will be in on status. RTC FPGA powered on, that is the clock related hardware which will be used for the hibernation time period, that will be in the on status. Global LED is in the on status. So hibernation with VSF. Some of the important point to note here, uh, the hibernation configuration is only available, the hibernation configuration commands, right? That is only available in the commander, not it is not available on the members. And when you configure the hibernation on a VSF stack, right? So you're configuring hibernation on a VSF commander. So the whole stack is going into the hibernation mode. It is not like only the commander will go into the commander will participate in the hibernation and members will not participate in the hibernation. Whenever you configure hibernation on the VSF, the hibernation will be applied to the whole stack. ISSU and hibernation is not compatible with each other. If both ISSU and hibernation falls around the same window, the hibernation will be backed off, allowing the ISSU to progress. If you look into the LED and logs, hibernation indicated via hibernation LED, that's also called as a global LED, which is blinking green during the hibernation. Event logs will generate when hibernation is initiated, enabled, disabled. So whatever the events you consider which is related to hibernation, whether you configure the hibernation, delete the hibernation configuration, switch is going into the hibernation, switch is rebooting because of the hibernation. So for all the events which is related to the hibernation, the events logs will be generated with the timestamps for the further troubleshooting if in case of any issues. Boot history tracks the hibernation and provide logs for entry and exit details. In addition to the event logs, right? If you see the boot history, that is by executing the command show boot history, you can able to see uh, uh, the entry and exit details of the hibernation. So below illustration shows the hibernation cycle. This is for the easy understanding of the hibernation configuration and the hibernation cycle. As a first type, user need to configure the hibernation configuration on the switches. Once the hibernation configuration configured on the switch, the user need to manually save the configuration, and then the switch will generate the event log, whatever the configuration you have configured, right? The hibernation now is enabled or hibernation periodic is enabled. The respective event logs will be generated. And in case of hibernate now, that is the immediate hibernation, the switch will enter the hibernation mode. In case of periodic hibernation, right, the switch will wait for the first hibernation schedule. Once the switch will hit the first hibernation schedule, it will enter the hibernation mode. During the hibernation mode, so these are all the hardware which will be in off status, that is PoE will be turned off, CPU is in the turned off status, fans are turned off. There's no traffic, CPU is turned off, there's no power to the connected devices or PD devices, that is PoE is turned off. So what is turned on during the hibernation? One is global status LED, which is blinking green, that is the indication of the hibernation. The other one is RTC FPGA on. It is a clocking hardware which is on for the time tracking purpose, and PSU remains on. If you have redundant PSU, one PSU will be in on state during the hibernation. And the switch will be in hibernation mode until the pre-configured timer expires. As soon as the hibernation timer expires, switch will wake up and start operating normally. And to exit force exit the hibernation, as we have discussed in the previous slide, to force exit the hibernation, there are a couple of options available. So by pressing the mode button and by doing the cold reboot or power cycle of the switch, with these two methods, you can exit from the hibernation before the predefined hibernation timer expires. Let's have a look into the LED details, mode button, and power supply units. In the below, we have taken 6300L hardware as an example to illustrate the hardware status in detail. So you can see here, this is the global status LED, which will be also acting as a hibernation LED. During the hibernation, this LED will be blinking in green. And you can notice the PoE is powered off during the hibernation. There will be no power supply to the connecting PD devices. Your switch fan will be turned off during the hibernation, and if your switch is having only one power supply, that particular power supply will stay on, stay powered on during the hibernation. If you have dual power supply, right, the one PSU will stay on and the second PSU will be powered off during the hibernation. You can see the mode button here. This button will be used to force exit the hibernation manually. This is the manual wake up option of the switch, of the hibernated switch. So if you want to force exit from the hibernation mode, then you can press the mode button. It will help you to exit from the hibernation forcefully. With 10.16 release of this feature, we allow two configurable hibernation modes. That is, one is hibernate now and hibernate periodic. Let's see the flow of both the modes. First, let's see the flow of the hibernate now. In the hibernate now, you have to configure the hibernation now configuration. And once you have called, you will get an option to save the configuration. You have to save the configuration. As soon as you save the configuration, right, in the hibernate now, the switch will enter immediately in the immediately into the hibernation mode. So before going into the hibernation mode, it will generate the event logs, and during the hibernation, the hardwares like CPU, fan, and PoE will be turned off, and the other hardwares like global status LED, clock related hardware, and the PSU is in the on state. The switch will be in the hibernation mode until the expiry of the hibernation timer. And as soon as the hibernation timer expires, switch will wake up and start operating normally. And when you log into the switch and have a look into the boot history, right, you can see the you can see in the event logs as well as in the boot history, you can see the event logs generated related to the hibernations. When it comes to the periodic hibernation, the flow will be same except some couple of differences. I'll come to those differences. As a first step, you need to configure the periodic hibernation and you need to save the configuration. But requirement. The below illustrates some of the example where hibernation interrupted as per the requirement. This is what I discussed previously, means in some certain circumstances or as per your business requirement, if you need to manually wake up the switch from the hibernation, that is the force exit of the switch from the hibernation mode. Uh, you can do that by pressing the mode button or power cycle of the switch. So let's see this particular illustration where we can see some of the difference between the hibernate now and hibernate periodic option. First, in both the hibernation modes, we need to configure the hibernation, and after configuration, we need to save the configuration, and the hardware status like hardwares like PoE, fan, and CPU will be turned off during the hibernation, and PSU, status LED, and clock related hardware are on during the hibernation. With Hibernate now, the switch will enter the hibernation immediately, and by pressing the mode button or power cycle the switch, you can abort the hibernation and switch reboot and generate the respective event logs, and no further hibernation in case of Hibernate now. At the same time, if you consider the hibernation periodic, the switch will wait for the first hibernation schedule to hit. As soon as it hit the start time of the first hibernation schedule, it will enter the hibernation, and if you press the mode button or power cycle button, it will abort the hibernation and reboot and generate the respective event logs and start operating normally. But in the periodic hibernation, again, the switch will wait for the next hibernation schedule to hit by the switch. So as soon as the switch reaches the time of the second hibernation schedule, the switch will again enter into the hibernation mode, and so on. Okay, with respect to the configuration, there are two options available for the hibernation configuration. As we have seen in the previous slides, there are two modes available. That one is hibernate now and one is recurring or periodic hibernation. Let's see one by one. First, we are going to see the hibernate now or immediate hibernation. To configure immediate hibernation, we have a command called hibernate now with the end time. End time specifies the hibernation end time in the month, date, hour, and minutes format. End time is mandatory. If you are not configuring the end time, or if you are using the incorrect format or incorrect end time, then you will get an error on the console. Hibernation periodic, it will enable a recurring hibernation mode and configure recurring hibernation option, but it does not hibernate the switch immediately. The command available is hibernation periodic, and you will get the option of recurring days. That is how you want to configure the hibernation. Either you need to configure it for daily, weekends, weekday, or any specific day. And you need to provide the details of start and end time of the hibernation. That is the time period configuration is required. Multiple periodic recurrences are supported as per the requirement, which means each day can have up to 10 hibernation time slots. This enables granular control over the hibernation activities. And also, you can see up to 7 distinct daily profile, one for each day of the week, can be configured. Let's have a look into the Hibernate Now configuration details. Hibernation Now can be configured with the command Hibernate Now followed by the end time. End time is mandatory, and as per the timing requirement, right? End time must be at least 5 minutes ahead of the current system time. This is to ensure a minimum hibernation duration. So if the specified end time is missing or improperly formatted, the system will display an error message, and without the end time, hibernation will not be activated. So once you configure Hibernate Now with a valid end time, the system will ask you to save the configuration. You need to save the configuration, and as soon as you save the configuration, right, the switch will immediately go for the hibernation. Please make a note, hibernation in Hibernate Now option, hibernation begins without checking for ongoing traffic or any activity. Let's have a look into the configurations of hibernation periodic. Periodic hibernation can be enabled with the command hibernation periodic. This will enable the periodic hibernation. So once the hibernation periodic is enabled, you can continue with configuring the profiles. That is hibernation periodic And if you want to configure it for daily, you have to give the option daily, or you can schedule for any specific day. You have the options available. If you want to configure it for the weekends, you have the options available. If you want to configure it for the weekdays, you have the options available. And once you have selected the profile, that is, if you want to configure it for daily or any specific day or weekdays or weekends, you need to configure the time period, that is start and end time of the hibernation on that particular day or particular weekends or weekdays, when the switch is going for the hibernation and when the switch needs to wake up from the hibernations. And with respect to the recurring hibernations, right, or the periodic hibernation, each day can have up to 10 hibernation time slots. This enables granular control over the hibernation activities. And also up to 7 distinct daily profiles, one for each day of the week is supported. In summary, with recurring hibernation, it supports broad and fine-tuned scheduling, ideal for the environments with variable activity patterns, and reduce manual efforts through automated and recurring configurations. Let's see the configuration using REST API. Below are some of the examples of scheduling hibernation using the REST API. The first example you can see here, this example illustrates the configuration of immediate hibernation. That is, this is a curl which is used to configure the immediate hibernation. You can see the immediate hibernation with the end time configured here. The second example, you can refer it to configure for the recurring hibernation on a specific day and specific time period. You can see here the hibernation mode configured is recurring and hibernation recurring configuration with the specific dates and time. Monitoring of hibernation. Let's see what and all the options available for the monitoring of the hibernation, and what and all the show commands available to see the hibernation status. First, take a look into the show hibernation command. So if you see here, it will get you the status of the periodic hibernation, either it is enabled or disabled. And if it is enabled, it will give the periodic hibernation schedule. It will display you the periodic hibernation schedule, whether the hibernation is configured daily, weekends, weekday, or any specific day. And most importantly, it will give the details of the upcoming hibernation time and upcoming wake up time. That is the next hibernation schedule, when it is scheduled, after how many hours or how many days the switch is going for the hibernation, and when the switch will wake up from the hibernation. So all those details will be displayed in the output of the show hibernation. And if you there are some customizable options available with the show hibernation. With the show hibernation, you can see some specific details like daily hibernation or any specific days of configured hibernation, or weekends or weekday schedule. You can see as per your specific needs. Let's have a look into the best practices, which is very important to consider while configuring the hibernation. With immediate hibernation, end time is required as a required prerequisite to configure immediate hibernation. End time is a mandatory when configuring the immediate hibernation. The switch will not enter to the hibernation without configuring the end time. Recommendation is to set the end time to be greater than the total time required for the system to shut down. This will ensure that the system has enough time to complete the shutdown sequence before attempting to wake up. With periodic hibernation, the user must always ensure that the end time of the last hibernation configuration of the previous day is less than 5 minutes from the start time of the first hibernation configuration of the following day. So for example, hibernation on every Monday from 7 p.m. to 11:59 p.m. Hibernation on every Tuesday from 12 a.m. to 9 a.m. is treated as a continuous hibernation configuration from 7 p.m. on Monday to 9 a.m. on Tuesday. So if you configure a schedule like every Monday from 7 p.m. to 11:54 p.m. and Tuesday from 12:01 a.m. to 9 a.m. It will not be treated as a continuous hibernation, but it will be treated as two separate schedules of hibernation. Proper planning and execution of hibernation as per your requirement is required to avoid any traffic disruption issues. Careful attention must be paid to the PoE devices, STP configurations, convergence time, system restore while dynamic protocol in use. These factors are critical because any disruption in traffic, particularly when the switches go into the low power state or hibernate, can cause significant network instability and service interruption. So, critical consideration before enabling the hibernation is PoE, that is, ensure the connected PoE devices can tolerate power loss or scheduled accordingly. With respect to the STP, please review the STP configuration and the convergence time. Hibernation may cause topology changes leading to delays or loops if STP isn't optimized. When it comes to the dynamic protocols like DHCP, LLDP, and EPOL, uh, these may experience timeout or state loss during the low power transition. Manually save the configuration as a cautious measure before the switch going for the hibernation. Let's get into the demo. In the demo part, we are going to demonstrate Hibernation Now configuration as well as Hibernation periodic configurations. We are using a lab network where we are using a 6300 switch, which is the uplink of the 6300 switch is connected to the lab network, and we are connected to the lab network remotely. And we are accessing the 6300 switch for the hibernation from a remote location. Okay, let's log into the switch and we are inside 6300M switches. First, we are going to configure the Hibernate Now option, that is the immediate hibernation. I'm going to demonstrate you the configuration of the immediate hibernation, and you can see as soon as you configure the hibernation, switch will immediately go for the hibernation mode. Okay, let's verify if we have any hibernation configuration. Show hibernation. We do not have any hibernation related configuration here. So let's confirm the switch timing. Show clock. Okay, to configure the hibernation now, as I said before, we need to use the command hibernate now. Hibernate now. And if you see the options, right, it is the end time. If you're not providing the end time, let's see what's going to happen. So I'm not providing the end time, it is going to give the incomplete command error. So if I randomly type some of the uh, timings, then let's see what. So you can able to see the specified hibernation end time is invalid. The command requests the hibernation end time in month, date, hour, and minutes formats. Without this format, it is not going to accept the command. So let's configure hibernation now. And what is the system date and time? It's 05 14 12 26. Yes, you can see the system is going for the hibernation. That is, as soon as you configure the hibernation, right? In this hibernate now option, the switch will immediately go for the hibernation. So you can see here hibernation in progress. Please be patient. And once that is done, before going into the hibernation, it will generate the event logs. Here you can see reboot reason hibernation required. Now the switch is entered the hibernation and the switch is in hibernation mode. Let's wait for 5 minutes and see how the switch will wake up from the hibernation and what and all the logs we can verify. You can see is waking up from the hibernation. Now once the switch is boot up completely and start operating normally, we can verify the logs and the event logs. Now the switch wake up from the hibernation. Let's log into the switch. And if you give show hibernation, right? So there is none. Actually, you have configured one time hibernation, that is hibernate now. So there is no further hibernation will be occurred on this particular switch. So if we see the show boot history, you can see here on 14th of May 25, 12, 26, power down due to the hibernation and wake up due to hibernation trigger. So in this way, the boot history tracks the hibernation entry and exit. And if you want to see the information in the event logs, you can see the event log after the switch is wake up from the hibernation. It will log the event like module rebooted, reason, power down due to the hibernation, and wake up due to the hibernation timer trigger. So this is the demo of Hibernate now, that is the immediate hibernation. Let's proceed with the periodic hibernation demo. Let's log into the switch. Just verify if any hibernation is already configured. There is none. You can see recurring hibernation is disabled here. And before proceeding with the configuration, let's verify the timing configured on the switch. Show clock. Okay. Okay. Now proceed with the configuration of periodic hibernation. Configuration terminal. To enable periodic hibernation, we need to use the command hibernation periodic, enter. So you can see here this command will enable recurring hibernation mode and hibernate the switch according to the configured recurring hibernation start and end time. Okay, I'm proceeding with S. Now the periodic hibernation is enabled. You can verify that one with the command show hibernation. You can see the periodic hibernation is enabled. Now we have to proceed with configuration of the profile, means as per our requirement. To do that one, hibernation periodic, if you put the question mark, you will get multiple option to configure different profile as per the business requirement. So you can configure it as daily, you can configure it on any specific day, or you can configure it on weekends, weekday, etc. So let's proceed with configuring it daily. Enter. Now we need to define the time period, that is start and end time of the hibernation. Time period, if you give the question mark, it will see the start and end time. Specify the hibernation start time and end time in hours and minutes format up up to maximum 10 entries. As I mentioned during the presentation, you can configure up to maximum 10 entries. So now we have configured the time period. Now exiting out. Now verify the configuration with the command show hibernation. Now you can see that recurring hibernation has been enabled, and this is the recurring hibernation schedule. That is, every day it is going to the hibernation will start at 10:35, and the switch will wake up by 10:40. That means by 10:40 the switch will come out of the hibernation. And you can also see here upcoming hibernation time is Thursday, that is today, uh, 10:35, that is hibernation after 3 minutes from now, and it will wake up after 8 minutes 45 seconds from now. And in the meantime, you can verify the event logs as well. Show events minus R. You can able to see the events generated for hibernation enabled, recurring hibernation enabled, and the schedules, the profile, whatever you have configured for all the things, the event log has been generated. Let's verify this show hibernation again. The switch is going to hibernate in 24 seconds. I just forgot to say the configuration. It is very important because we have multiple recurring hibernation schedule, right? So after the reboot, the configuration should be persistent. You can see the time has hit already, and the switch is entering the hibernation mode now. We're ready to get the event logs. Yes, you can see now the event log has been generated and the switch entered the hibernation mode now. And as per the pre-configured timer, switch should wake up by 10:40. Let's wait for the switch to automatically wake up. Now it's almost time. You can see the switches started booting. It will come up in some time. Now the switch has completed the boot up process and it is up and ready now. Let's log in back. First, let's verify the hibernation configuration. Show hibernation. So you can see now this the first hibernation schedule has been completed, and if you come here, upcoming hibernation time, right, it is scheduled for tomorrow at the same time 10:35, and the wake up time is tomorrow 10:40. So in this way you can configure the periodic hibernation. Let's verify the event logs as well. You can see here the event log is generated for the power down event, and if you see the show boot history, it will record the hibernation exit and entry details. That's all for periodic hibernation. So event logs got generated, reboot reason hibernation requested, and the switch entered the hibernation mode now. So let's try buying the power cycle of the switch. I just initiated the reboot of this particular switch, or the power cycle of the switch, and you can see the switch started to reboot and it will come up soon. And please remember here we have configured the wake up time as 11:15. Now switch is booted back up. Let's log into the switch. Verify the clock, and it is still 10:54 and we are out of the hibernation mode, right? So this is the case of forceful exit of the hibernation. This can be done as we discussed previously, right? This can be done using by pressing the mode button, or you can power cycle the switch. That's it about the force exit of the hibernation. Let's see a demo of the one-time hibernation using the job scheduler. That is, as I said before, right? A single occurrence of the hibernation is not supported, and we can achieve that by using hibernation in combination with the job scheduler. So let's try that one. Show hibernation. It is disabled. Go to the configuration mode. Create a job. And what and all the commands you're going to use. We need to specify those commands in the CLI format with sequence numbers. Configure terminal. And second command we are going to use before to that I just need to verify the switch time. Okay. CLI hibernate now 05:15. CLI, we need to give S in the CLI, that is when it is prompting to save the configuration. We have included all the commands which is related to Hibernate now. Now we are going to schedule the job. Trigger, and you at the time you need to give 10:58. Okay, and we need to enable the schedule. Now let's just come out of it. Show job. Yeah, we can see the job has been scheduled and it is enabled, and the status is running, and the trigger is not yet done, right? So let's wait.
So you can see the configuration has been triggered from the job scheduler and the switch is entering the immediate hibernation mode. So in this way, with combination of job scheduler, right, you can configure the single occurrence of hibernation. That is, for any specific date and time, you can configure the hibernation. That's pretty much covers the demo of the hibernation feature, and that's all we have for the hibernation feature today.
Thank you all for your time.